Hello, pre-calculus student. This video is for chapter 5.4, really into last part of chapter 5.4, trying to use right triangle trigonometry to solve applied problem. So first, we want to talk about some term first before we solve work problem. A lot of these work problem involve two terms called angle of depression and angle of elevation. So I have a picture here, but it's not very clear. Angle of depression is about someone, an observer, standing in a high place. In this case, it's on the top of a tower, but it could be on the top of a building. So this is the observer. And then the observer look down and see an object. So this is the lines, the sight, line of sight, and this is the object that the observer observe. Normally when we look straight, right? Parallel to the horizontal, but because it stand up on top of a building, it's in a particular height. So when it look down to see an object, there is an angle that the eye need to go down, depress down. So this angle is called angle of depression. The angle that it makes with the natural height eyesight that you don't, normally when we stand up and we look horizontally. But if we want to look down, we depress an angle where we look down. So this angle that the line of sight make with the horizontal is called angle of depression. It's really because the object is below you. And then the other way would be, let's look at this, the original picture, is the observer is here. So the angle is always close to the observer. And then it needs to look up to the top of a building, right? The object now is here. So normally if you look horizontally. Well, this is exaggerated that the observer is actually on the ground. But roughly speaking, if this is really high, you can approximate that. The observer has to look up. The eyesight instead of horizontal would need to look up. This is the line of sight. So this angle that you rotate up to in order to see the object is called the angle of elevation. Angle of elevation. I don't know if you see it. It's very small. Angle of elevation. So that's what it is. So if your observer is below the object, you need to look up to see it. This angle that makes with the horizontal is called angle of elevation. If the observer, whereas if the observer is on the high place, you need to look down to observe an object, then the angle it make with the line of sight with the horizontal is called angle of depression. Okay, so when we solve a applied problem, work problem, a lot of them would mention this angle of elevation and angle of depression because in this particular chapter we were given an angle, and the angle is usually the angle of elevation and depression. So when we solve this work problem, we usually need to sketch a diagram or picture, and if it's related to an observer, an object, you want to mark the line of sight and mark the angle of elevation or depression. And then you have to decide which function to use. So what do you need to know? So I have three functions normally that we use. Sine, right? Cosine, ka, and TOA, which is tangent. So what happened is you always have an angle. It would be, and then what you do is you look at what side is given to you and what is the unknown side that you want to do. You decide it on the trig function. So if you have O and H given, or O is given and H is missing, but your angle is related to that angle, they're O and H, then you use sine. The angle that's related to the two sides that you have in mind is A and H, then you have cosine, etc. So let's do an example. I am going to do 1, 2, oh, there's only, how come this is 10, so this would be 11. And well, okay, so it's a little off. The numbering is a little off, so change it back. I'm gonna type it up. So okay, The numbering is a little off. So this should be, I think I add an additional example. So it's a little off, 2 and 3. So we'll do, in this video, we'll do all of them. Okay, so first is, okay, so this I draw a picture. So example 9, angle of elevation to the top of a building in New York is found to be 9 degrees. So someone is observing the top of a building in New York and the angle of elevation is 9 degrees. So what happened would be you would have an observer on the ground from the ground, right? From the ground. So this is the observer. The highest line of eyesight is to the top of the building. And this angle of elevation is always relative to the horizontal, that's 9 degrees. How far is this, what is also given? From the ground at a distance of 1 mile. So this is 1 mile from the base of the building. So this is the building, observing the top is 9 degrees. So far so good. And then we want to find the height of this building. So this is h, okay? Yeah, well, h is not a very good variable because its hypotenuse is also h. Let's say x, right? So which is the height of the building? We want to find it, and we were given 1 mile. But when we find the height, we want it to be in feet. So we want to convert this in feet also. So 1 mile is 5,280 feet. So now everything is in feet. So you can see that I have one side, two side, and an angle. One of the side that is not given, but it is my interest of solving it. Relative to the 9 degree, this x is a opposite, right? And the one that is given is an adjacent. So I have O and A. So what function should I use? O and A is tangent, right? So we would say tangent 9 degree, tangent of that degree should equal to O, which is x, over 5 to x0. Okay, now this is the equation. We want to solve for x. X would equal to 5 to x0 times tangent 9 degree. Why? Because I multiply both sides by 5 to x0 to cancel it, right? Time 5 to x0. So this cancel and I have x on this side. So all you need to do is to put in the calculator 5 to x0 times tangent 9. So here. So turn on 5 to, I did it already. 5 to x0 times tangent 9 is x36.3. Oh. And this is in feet. That's how it is. So the lesson learned is you always find the angle, you find the two sides, including the one that you don't know, and you look at SOHCAHTOA as to which one is would match the two sides that you have. You're looking out the window at the top of a tower. The height of the tower is known to be 50 feet. So I know a tower, 50 feet. You look out from the window at the top. So your observer is in the top. From the top of this building, you measure the angle of depression of a car to be 30 degrees. So because you are looking down, remember the angle of depression is the angle that it makes with the horizontal. This is 30 degree, and you look at car here. How far is the car from the building to the nearest floor? So to the nearest foot. So we want X. So we want to know the car is obviously on the ground. So we want to know this. So this is a right triangle. One angle that I have, but this triangle I don't have any angle. It turns out that if this is 30 degree by the angle, alternate interior angle, like sometimes people call it the Z theorem is if you have two parallel lines and one angle between them, this angle at the two sides of the Z is congruent. It's called ordinate interior angle. So if this is 30 degree, this is 30 degree. So now I have an angle in a right triangle, and my thing of my line of interest is X and 50. According to 30 degree, this is opposite. According to the 30 degree, this is also adjacent. Again, this is tangent. So we would say tangent 30 is equal to 50 over X. TOA, right? TOA, O over A. Now I want to solve for this, so I will use times X on both sides. I want to clear the denominator first. So I would have X tangent 30 is equal to 50. And then to do X, I divide by divide tangent 30 on both sides. Well, tangent 30, I actually can get it from the special angle, but this is a work problem. We don't need exact value. So I will just put in the calculator. Okay. If they need exact value, you don't. Okay. So it's what, 5? 50. 50. Okay, clear. 50 divided by, it's not times, right? Tangent 30. And when you do this, you want to make sure that your calculator mode is in degree. Okay. If it is in radian, it doesn't work. 86.6. And 86.6. Is it in feet? It's feet. Okay. So this is 86.6 from. 11. How long a ladder is needed to reach a windowsill? So there's a windowsill. This is the wall. Windowsill 50 feet. So there is a window here, and then 50 feet above the ground. Oh, okay, it must be a big building. So this is 50 feet above the ground. If the ladder lean against the building with an angle of 75 degree, so they want to reach this window. So leaning at the long ladder must be 50 feet. But this make a angle of 70 with the ground. So the angle, there's no one observing anything, but the ladder make an angle 75 with the ground. So draw the ladder here. They want to reach this window, and with the ground is 75 degrees. So how long a ladder is needed? So let's say X is the ladder. So I have one angle, two side, one I don't know. This is 50. So I call it relative to 70. This is height. H. Yeah, this is hypotenuse. Relative to 75. This is O. Right, opposite. So which SOHCAHTOA, which trig function would allow me to set an equation? I have O and H, so I would say sine of that degree should equal to O 50 over H X, right? 50 over X. So again, I need to clear the denominator. Because my X is in the denominator, so multiply X on both sides. But after that, I still don't know what my X is, because it's with 75 degree equal to 50. So I did divided by sine 75 degree divided by sine 75 degree. My X would be, so sometimes you multiply and it would be done. Sometimes you have to divide. Divided by sine 75 degrees. So put in the calculator 50 sine 75. 50 times sine 75. 48.3. X is equal to 48.3. Feet. Okay. So the letter need to be no 55. I think I'm not 100% sure this is right because it doesn't. Oh, I do multiply. It should be the y. Right, because it should be longer than 50, like larger than 50, 51.8. Okay, don't make a mistake like what I did. 51.8 is the y. Yeah, it makes sense. If this is 50, this is a letter has to be longer. So it's because I punched in the wrong one. Okay, given a triangle below, find x. Now, this is a little harder question. Um, I, I don't know that this is a right angle. I only know part of it is a right angle, right? So how do I find it? I need the whole x. I have, so what you can do is, oh, I have this x actually is from two right triangle, the first right triangle and the second right triangle. So you can change it to, you can have two label for them, A and B, right? X would be A and B add together. So let's use the first right triangle. I have B that I want to solve. I have one angle. This is adjacent, right? This is adjacent relative to 39 degree. And then relative 39, 82 is all opposite, right? So I will set up tangent 39 degree is equal to TOA, right? TOA opposite, which is 82 divided by B. And then I multiply B on both sides. B times 39 degree would equal to 82. And I divide B is 82 divided by tangent 39. That's B. And then, so this is one part. And then the other right triangle, if this is 90 degree, this is 90 degrees of right triangle. Relative to here, I have A, and relative to 63 degree, I have also a O. So this is exactly the same. So, but it is 63 degree is equal to 82 over A, right? TOA. And then I do the same thing. A tangent 63 would equal to 82. A is equal to divided by tangent 63 on both sides. So I have B and B. So X would be equal to A plus B equal to 82 over tangent 63 plus the same 82 over tangent 39. So now I'm going to put in the calculator. You put it in, and that would be x, a plus b. So 82, the y, remember, tangent 63, close, okay, plus 82 again, divided by tangent, I forgot, what is it? 63 and 39. 39. 143.0. 143.0 unit, right? 143.0 unit. So that's it. That's how you do it. So sometimes you have two right triangle next to each other. Example 13, a 400-foot tall monument is located in a distance. So this is the monument. It's very tall. It's 400 feet. From a window in a building. Oh, so there is a building also from the ground. But you look out from a window. We don't know how tall is the building. A person determined the angle of elevation to the top of the building is the top of the monument. Yeah, is the angle of elevation is horizontal, right? Although it's only on the window, it's always horizontal. That's 18 degree because normally you just look straight. And the angle of depression to the bottom of the monument, so you look to the bottom of the monument. You have to decrease 3 degree. How far is the person from the monument? So, how far is the person from the monument? Well, it is in the window. So I think we want X. Okay. Hmm. So is there any side that we don't know? that we know, we don't know any. So we have 3 degree, not 30 degree, 3 degree. Let's say this is A and then this is B. But A plus B is 400, so the other one is 400 minus A. Can you do that? So the total is 400. If this is A, then it's 400 minus A. And this is X. So let's look at the first right triangle, which is 400 minus A, and then X and 18 degree. And then let's look at the second right triangle. It's like this, 3. But this is A, that's it, right? 3 degree. So let's set up the sine and cosine or tangent thing. So relative to 18 degree, this is O and this is A, right? So we would say tangent 18 degree is equal to 400 minus A over X. And then the other one will be tangent 3 degree is equal to, this is also X, O over X, A over X. So we have two equations. What happened is we can multiply X on both sides and solve. Yeah. Okay, so we multiply X on this side. So X tangent 3 degree is A. And then what we can do is use this to plug into the first one. Because A is X tangent 30, so continue with this, we would say tangent 18 degree would equal to 400 minus X tangent 30, not tangent 3 degree. Wow. Tangent 3 degree over X. So X is both here, so let's multiply X on this side. X tangent 18 would equal to 400 minus X tangent 3 degree. How do I solve? I have X on both sides, so move the X over. So plus X tangent 3 degree on both sides, plus X tangent 3 degree. So we should be able to solve because we only have the unknown X. So both of them are X, so X tangent 18 plus X tangent 30 is equal to 400, right? So I factor X out, tangent 18 plus tangent 3 degree, not 30, so don't write 30. 3 degree is equal to 400. So X would equal to divide this by, on both sides, I would have 400 divided by 18 plus tangent 3, or degree. So now ready to go. So this is parenthesis. 400 divide tangent 18 and tangent 30. So let's see how we do it. 400 divided by tangent 3 degree, close, plus tangent 18 degree. Doesn't matter which one go first. Oh, press enter. 1060. So the X distance from the monument is 1060 feet. Okay, so I'm going to stop here.